Hey y'all, welcome to Miss Clarke's chemistry class. I'm here to help you better understand what you learned in class. Are you here to learn more about periodic trends? Sometimes they can be a little bit tricky. So by the time this video is over, you are going to feel much better about understanding how a trend goes down a group and across a period. So go get your notes, go get something to write with. If I'm saying something that's already in your notes, you need to highlight it. You will see that again. That was very important. Look, you might have to pause, rewind, watch something over again. I know, we hate to do stuff like that. But if that's what it's going to take for you to get a good grade in chemistry, isn't it worth a few extra seconds? You've got your notes, you're ready. Let's start talking about periodic trends. The three periodic trends that we're going to talk about are atomic radius, ionization energy, and electronegativity. We're going to talk about each one of these. We're going to get its definition, see the trend on the periodic table, and try to understand why each trend is as it is. The first periodic trend we're going to talk about is the atomic radius. That just means the size of the atom. If you have two of the same atoms bonded together, and then you take the distance between both of their nuclei, cut that distance in half, that's the atomic radius. As we go down the group, the atoms get larger. That makes sense. We're adding energy levels. Remember, the period numbers coincide with how many energy levels there are. So up here with hydrogen, 1 energy level. As we go down, we add energy levels, add shells, add energy levels. Francium, 7 energy levels. So of course, as we go down and add energy levels, the atom is getting bigger and bigger and bigger. Now the period trend is that it decreases as you go across the period. At first glance, that doesn't make sense because as we go across the period, the atomic number gets bigger and bigger and bigger, which means we're adding more protons, we're adding more neutrons, we're adding more electrons. Shouldn't the atoms get bigger? Why are they getting smaller? The more positive protons you add and the more negative electrons you add, that atom just gets tighter and tighter and tighter as those opposite charges just pull on each other, making a smaller atom. And this is due to Coulomb's law, which says opposites attract. And so this is what that trend would look like on the periodic table. We're getting bigger as we go down. We're getting smaller as we go across. That means francium is the biggest atom and helium is the smallest atom. So let's look at the ionization energy trend. We decrease down the group because the atom gets bigger down the group. Ionization energy increases across the period, and it's because atoms are smaller. The ionization energy, it's the energy required to steal an electron from another atom. The ionization energy is a direct relationship to the atomic radius. Let's think about this for a second. The bigger the atom gets, the farther away from the nucleus the valence electrons are. If the valence electron is way far away from the nucleus, it is easier to steal. So francium, the biggest atom, it's 1 valence electron way far away from its nucleus. Another element can just come snatch that right away and the nucleus won't even miss it. But if we look over here at something like fluorine, something teeny tiny, it's got all 7 of its valence electrons really close to its nucleus. It's going to be very difficult to steal an electron. Remember, those valence electrons are on the outermost energy level, and when those electrons are closer to the nucleus, they are harder to get. That is why as we go across the period, the ionization energy increases. And this is what that trend looks like on the periodic table. So the ionization energy is going to decrease down the group because atoms are getting bigger, and ionization energy is going to increase across the period because atoms are getting smaller. The next trend, electronegativity. Now, electronegativity is the ability to gain an electron, and fluorine is the absolute best at this. So let's look at the electronegativity trend. It's going to decrease down the group and increase across the period. The closer we get to fluorine, the more electronegative something is. So this is what the electronegativity trend looks like. It's going to decrease down the group because as you decrease down a group, the farther away from fluorine you get. We're going to increase across the period Because as we go across the period, the closer to fluorine we get, because fluorine is the most electronegative. In my list of trends, I didn't list reactivity. I know, I'm adding an extra trend. It's because I think it's really important. If you've watched my previous video about periodic table, you already know that metals and nonmetals are opposites of each other. If you've not seen it, you need to go check that out. So, again, back to that. Metals, nonmetals. They're opposites of each other. So their trends are opposites of each other as well. So if we look at the metal reactivity trend, it's going to increase down the group and decrease across the period. And if we were to look at non-metal reactivity, it's going to decrease down the group and increase across the period. Exactly opposite, which is going to leave this area down here the most reactive metals, and up here the most reactive non-metals. Okay, so by now you should feel like a pro at atomic radius, ionization energy, electronegativity, and reactivity trends. And if you don't, rewind, watch it again. Repetition, that's the key to success. If you're finding this helpful, don't be afraid to go look in the description. I have several other tutorials listed there. Also, do you have a friend that's struggling in chemistry as well? Share this video with them. Maybe it will help them as well. Until next time, bye y'all.